Hi guys, welcome back to Data Every Day. Today we're looking at a dataset of automobiles and trying to predict the price of a given automobile based on a series of 25 features. Price is at the end here. It's going to be a regression task and we're going to use XGBoost to make our predictions. So I'm going to import NumPy and pandas just for dealing with the data. Then we'll use the standard scalar and train test split function from sklearn for pre-processing, and we'll get XGBoost for the actual model training, and then we'll get a metric, R-squared score, from sklearn to evaluate the performance of our model. Alright, so just type getting started, and I've imported the imports, and now let's load in the data using pandas.readcsv. And we can get the file path right over here, just paste it in, and take a look. Alright, and the first thing to notice is that we can't see all the columns right now. So what I'm going to do is go into the console and type pandas.setOption max columns to none. This way we can just reload it and see all 26 columns at once. Okay, so there's a few things I'm noticing right away, which is that we have some -1 values, which I take to mean missing values. And we also have question marks, which also I'm taking to mean missing values. So let's get some info on the data. And it appears that there are no actual missing values in here. They've been encoded as either -1s or question marks. So let's start cleaning. And the first step here is let's replace -1s and question marks with missing values. So data.replace, this means that replace any cells that exactly match -1 and replace it with NaN, numpy.nan, and that's going to be data. Then we're going to do the same thing, except instead we're going to replace question mark with numpy.nan. Alright, let's see. Okay, there's another, before I actually execute this, I want to note some of these missing values are in numerical columns. So after I run this, I'm going to have to go back and, because technically this is a string, so these are being counted as strings as well. So even after I change these to missing values, I have to convert the column to a numeric column before I can fill the missing values with the mean. So let's replace, and then I'm going to take a look at the data types of each column. Actually, it would be more useful to actually just use info again. We'll notice, actually, how should I do this? I want to get the missing values and the type. So for example, what I mean is you can see there's some missing values in normalized losses, but the type is an object. And if we look up here, normalized losses is actually a numerical column, but right now it's being encoded as a string column. So we have to we want to change all of the numeric columns that are not actually numeric columns into proper numeric columns. So for column in, I'm going to make a list of all such columns. We're going to just change the type of the column to numpy.float. So as type and reassigning. Now we just have to collect all the columns where this is the case. So we're looking down here. Okay, actually this doesn't have to do with missing values so much, right? Let's just take a look at the data. And the D types. So I'm looking through, float looks good, object does not look good, because this is actually numerical and it says it's an object, so I'm going to throw him in the list. Alright, next, fuel type, that's object, aspiration, object, these are all objects. We get over here, wheelbase is a float, so we're good. Length is a float, we're good. Width is a float, these are all floats. Curve weight's an int. Engine type is actually an object column, so we're good. So far it's looking good. Fuel system is an object. I know this is boring, but we just gotta get through it. Bore is actually, okay, here's one. So bor is a numeric column that's being encoded as an object. So let's put bor in here. And stroke is numeric, and it's being encoded as an object. So let's put stroke in here. Compression ratio, that is properly encoded. Horsepower, an object, so let's put it in here, because it's actually numeric. Then peak RPM, also an object, so we'll put that in there. Peak RPM. City miles per gallon, that's properly encoded, don't worry about it. Highway miles per gallon, also properly encoded. And price is an object, so we need to include price here as well. Okay, so now with all of these columns, we're going to just turn them into float columns, because now they no longer have these question marks in them. Now they have missing values like this. So it'll be fine to turn them into, wait, what's wrong? Oh, it's not an underscore, it's a hyphen. Okay. Alright, so now, yeah, let's see. Let's take a look at the missing values remaining. So if we get the is an A matrix, that's just true or false whether or not there's a missing value in that location. So if we sum over the rows, we'll get the number of missing values in each column. And we know that anything that's numeric here can be filled with the mean of the column. So what I mean is this can just be filled with the mean of all the other values. So what we're going to do for column in data.columns, if data.dtypes subcolumn is not object, so if we're dealing with a numeric column, and data.isAnA.sum subcolumn is greater than 0, so and we have missing values, so let me write that. We can write for all numeric columns with missing values, data subcolumn equals data subcolumn dot fill NA. So this function will fill the missing values with a given value, and the value we want to fill with is the mean. So fill missing values with the column's mean. Alright, we run that. Let's take another look at our missing values. And most of them have been dealt with. We just have this final number of doors feature with 2 missing values, and he is categorical. However, you notice these are actually numerical values encoded as text, as strings. So I assume they did that because there's only really 2 values for it, 2 or 4. So it might be a good idea to one-hot encode this column because it is really it's sort of binary. It's either 2 doors or 4 doors. It's never like it's not really a continuous range of values. Similarly, I believe there's one more in here. Number of cylinders here, 4, 6, 5. Okay, so we have a few more values here, but they aren't exactly in a continuous range. So we'll take a closer look at that. Let's do this. Encoding ordinal features. So let's get well, how about I just okay, whatever. Let's get a list of columns. We'll make a dictionary that's going to map a column name to a list of the unique values in the column. For every column in data.columns, if data.dtypes subcolumn is object. So what we're doing is we're getting all the unique values in every object column. And this will give us a good idea of how to encode the columns. So you can see we have a few binary columns. Binary columns are easy to encode because you can just you can set them set one value to 0 and the other to 1. and there's your feature. Number of doors is actually also a binary column. The NaN value is not counted. Everything else, though, besides the binary columns, which look like these three here and this one, all the other ones are going to be one-hot encoded. So these are actually, we're not going to do ordinal. Because, okay, so originally I was going to make this an ordinal feature, where 2, 3, yeah, because it does have an order to it. I'm not sure if I should do that, because it's not really continuous. If you think about the meaning of the number of cylinders, there's some fixed values it can take on, and even though you may say, you know, it's debatable. It's hard to say. Because you can say that an 8-cylinder car is more powerful than a 2-cylinder car, so there is a sort of meaning of power there. But it's not clear because this. So like what I could do is actually encode these, make this a number 4, make this a number 6, make this number 5, and then the model would see that some is greater than the other, right? Whereas if I did a one-hot encoding, it would treat them all as equal and think of them as categories. So, yeah, why not just, we'll ordinal encode it. It's not really that hard. All we have to do is make a numeric ordering, which will be a dictionary that's going to map the text name to the actual numerical equivalent. So we have 2, 3, 4, 5, 6, 8, 12. So there's no 1. We have 2 maps to 2, 3 maps to 3, 4 maps to 4. Okay. We have 5 as well. 5 maps to 5. 6 maps to 6. And there's no 7. We just have 8 and 12 remaining. 12. Okay. And then it's very simple. All we have to do is, what's it called? Num of cylinders. We'll say data sub num of cylinders equals data sub num of cylinders dot replace numeric ordering. And you can pass a dictionary into the replace function to actually just apply all the mappings to the values in the column. It's really good. So if we run that, if we look at data, you can see where is it? Num of cylinders is now a numeric value. Okay, now that we have, okay, let me think about this. I want to deal with these missing values. There are these 2 remaining missing values that are giving me a hard time. So let's just encode num of doors first, so that we can fill in the missing values and then worry about the other columns. So num of doors, it's either 2 or 4. So what I'm going to do is I'm going to apply a lambda function to it. So num of doors equals the same column dot apply with a lambda function. It's going to map x, which will be a given number, map x to 1 if x equals 4. And here, you know what I'll do? Let's find the mode. Okay, 4 is the mode. So what I'm going to do is I'm going to fill the missing values with 4. We're not doing mean here because it's not a continuous range. So 4 is going to be, it's a default. Okay, I think what we should do then is 0 if x equals 2, else 1. So do you understand what's happening? We have some x, which is a 2 or a 4, and if it's actually a 2, we're going to make it 0, and otherwise we'll make it a 1. This will both apply 1 to if we have 4, but it'll also give 1 if we have a missing value. And at the end of this, we'll have a fully numeric column, and we will have no more missing values that way. So let's write this. Filling remaining missing values. Even though we did not use the fill_in_a function, now see that total missing values is going to be data.isNA. So we sum across the rows, and then we're going to sum again across the columns to get the total number. And we're completely done with missing values. Alright, one hot encoding nominal features. Alright, so let's make a one hot encoding function. Let's just say encoding nominal features, because we're also going to make a binary encode function. Binary features are nominal features, but they just take on two values, so it's a simpler encoding scheme. So let's make a binary encode function, and it's going to take in a data frame, a list of columns, and and positive labels, positive values. We're going to start by creating a copy of our data frame, and then for every column and positive value in zip of columns and positive values. So zip will just pair up the elements of columns and positive values element-wise into tuples so that we can iterate through them two at a time like this. So for each pair of column and positive value, data frame subcolumn equals data frame subcolumn dot apply lambda, and this is going to be very similar to what we had before. It will be a 1 if x is equal to the positive value for that given column, and otherwise it will be 0. And that's it. Return df. And then, so let's apply this. Let's look at the data. Okay, let's collect up the binary columns. So we have this thing. Let's take another look at this. Whoops. Okay. So let's collect all of our binary columns, binary features. Alright, so we have fuel type. Aspiration. Engine location. I think that's it. Yeah, because we already dealt with this one. I'm wondering if we should just include this down here. Okay, yeah, it probably makes more sense to do that, but whatever. Okay, we also then need some positive values, binary positive values. For fuel type, the positive value will be diesel. This is arbitrarily chosen. Aspiration, positive value will be turbo. And for engine location, positive value will be front. Okay. Now, data equals binary encode. We pass in data. We pass in some columns. Will be binary features. And some binary and some positive values will be binary positive values. Okay. Now let's take a look at data. All right, we can see that all of these binary columns have been encoded to 1s and 0s. So that was fuel type, aspiration, and engine location. 1s and 0s, 1s and 0s, and 1s and 0s. Okay, now let's make a one-hot encode function. So this is going to take a data frame, a list of columns, and a list of prefixes. And we're going to start again by creating a copy of our data frame. And let's just copy this. It's going to be the same way to start, where we're iterating through the columns, and instead of positive values this time, we're going to be iterating through the prefixes. So this is going to be prefix. And we're going to create a dummies data frame using pandas.getDummies that will just provide the one-hot columns for us for a given column. And we're going to include a prefix in the column names given by prefix, which is just one value in prefixes that's paired along with column. And then we're going to concatenate using pandas.concat the data frame and the new dummies columns right next to each other. And when we're done, we can drop the original column from which we created the dummies because it's no longer serving us. Alright, we have one hot encode, and now the remaining values, okay, let's see. So data equals one hot encode, and we're going to pass in data, columns, and prefixes. Now we have to define them. Let's get the columns first. So everything that wasn't binary here, so make, so I'll put it up here, nominal features is make. What else? We have body style, drive wheels, and then the last two there. Engine type and fuel system. Okay. Alright, let me just clean this up a little. And let's get some prefixes, which will be, how about MK for make, BS for body style, DW for drive wheels, and ET for engine type, and FS for fuel system. Alright, and then we will apply this with columns equal to nominal features and prefixes equal to prefixes. Okay. Now before we move on, let's take a look at data. You can see we now have 66 columns. We have all these one-hot columns at the end, and you'll notice that our entire data set is numerical now. So if I print total non-numeric columns, and I'm going to print out data.dtypes equals object dot sum. So it's all the sum of all the this is the number of non-numeric columns, and 0. Alright, so splitting / scaling. So now let's split the data set because we're fully done pre-processing it. We just have to scale it and we'll be done. So y equals data sub price, right? Price is what we're trying to predict, so that goes in y. So price, and we'll make a deep copy of it. And then x is going to be everything except price. So we're going to drop it from axis 1 and then make a copy of that. Alright, now let's create a new scalar object. This is a standard scalar from sklearn, and that's going to give each column mean 0 and univariance. We're calling the fit transform function on x and storing it back in x to get a scaled version. Alright, and then we're going to split into train and test set. Xtrain, xtest, ytrain, ytest, using the train test split function from sklearn, pass in x and y, and we'll specify a train size of 70%, and we'll include a random state just to reproduce the results. Then I'm also, because I'm using XGBoost today, we're going to make a validation set out of the train set. So xtrain, xval, ytrain, yval equals train test split, but I'm going to split on xtrain and ytrain. Train size here is going to be 80% because I can actually do test size. It's going to be 20% because we want to reserve 20% of it for the validation data. Alright, we'll also include a random state. 20 again works. Okay. Now we're going to convert the data into D matrices, which a D matrix is an XGBoost data format that it prefers to train on. In fact, I think you have to use it. We'll call it dtrain is going to be a D matrix from XGBoost that takes in xtrain, and the label will be ytrain. Alright, very similar. We're going to do it for the validation. So this one will just be on the validation data. Dval equals D matrix using xval and yval, and then this is going to be test. So we'll just grab those, test. Now we have these 3 D matrices, and we can begin training. So to train XGBoost, it's very simple. We just need to specify a number of parameters and store it in a dictionary. For a learning rate, how about we do 0.001, and a max depth of a given tree, and the tree boosting will be 6. That's just the default value. I'm not really going too heavy in the model optimization today. Alright, to train, we just do xgb.train. We pass in the parameters and dtrain as what we're training on. And we'll also specify the validation data, which will be dval, and we'll call it eval. The number of boosting rounds is like, okay, so we're just going to run it for 10,000 and have early stopping enabled. So that after it sees that the validation performance is not doing so, after it stops improving for 10 rounds, it will stop the training, and we'll be able to get the optimal results that way. So let's go ahead and train it, and this should be round actually. Alright, so that's going. It's still going. This is going to take just a moment. Even though it's only 10,000 rounds, there's only 200 examples in this data set. So, we can't expect to get very good results from a 200 example data set, but maybe we'll get some decent results. Let's see. Okay, finished, and let's gather the results. I'm going to create a vector of true values for y, and that's going to be a NumPy array consisting of the values from ytest. And let's specify the data type as numpy.float. Then our predicted values will be numpy.array with the model predictions. So I'm calling model.predict on the test set, dtest, and also specify numpy.float. Alright, I misspelled that. Okay, now we can get the R² score using, this is from sklearn, I imported earlier, and we're passing in y true and y predicted. And how about I print it out? R² score, and we'll do one of these. We'll display 4 decimal places. Dot format. Pass this in. And we got an R² score of 0.45. So not great, but it's actually not too bad considering we have only 200 examples. Now I'm sure you could make this better. This is just sort of a quick run through, quick data cleaning, and quick training. So that'll sum up today's video. Thank you so much for watching. I hope you enjoyed it. If you did, make sure to subscribe and hit the bell for more content, and leave any comments you have in the section below. I'll see you guys tomorrow. Have a fantastic day.